change this, please. So this is equal to this angle over here. Okay, that I'm highlighting in yellow now. It's equal to 90 minus 30 minus 48.02. So that angle over there is equal to 11.98. Now, how I get the 30 degrees down here is, if you look back at the figure, right, this angle is 30 degrees. Okay. So when that's the case, the angle down here now will be equal to 180 minus by 120 minus by 11.98. So this will be equal to 180 minus 120 minus 11.98 is equal to 48.02. So from here, we can form sine 48.02 divided by that length is equal to, so CD we are given that is equal to 0.4. Okay, so 48.02 is CD. Then we can use sine 120 will be equal to point D to IC. And then finally, sine 11.98. And then this will be equal to point C to IC. Okay. So from here, we know that D to IC will be equal to sine 120 divided by sine 48.02 multiplied by 0.4. Okay, so sine 120 divided by sine 48.02 times by 0.4 is equal to 465.994 times 10 to the power minus 3 meters. Let me do it again. So sine 120 divided by sine 48.02. Yep. Then we have C over IC, or CIC, sine 11.98 divided by sine 48.02 multiplied by 0.4. Okay. Sine 11.98 divided by sine 48.02 times 0.4. 111.69. Okay. So DIC is a longer distance than CIC. Okay. So from here, we know that VD, let me zoom it out, VD is equal to omega DIC multiplied by D, distance from D to IC. So we know our VD, right? The VD is equal to 2.446. So 2.446 is equal to omega D to CD multiplied by DIC is 465.994 times 10 to the power minus 3. So omega DIC is 2.446 divided by 465.994 power minus 3 is equal to 5.249 radians per second. So to get Vc, you have to put in omega CIC multiplied by the distance CIC. And we know that this is also equal to 5.249. So you get 5.249 multiplied by CIC, which is 111.69 times 10 to the power minus 3. So 5.249 times by 111.69 power minus 3 is equal to 586.261 times 10 to the power minus 3 meters per second. Okay. I'm going to look at what we had before. We had 0.585. Over here, we have 586.261. Okay, there's some rounding error. I think the rounding error was probably the one that we did in the relative motion analysis. So if you look at the math, it's all high school math. You get what I mean? Right? You don't need to do vectors over here. But you have to be very sure about the direction. Are we clear? Okay. Now, I'm going to do one more problem. Okay. But before I go on in the term test, I will tell you what to use and what not to use. This example is for learning purposes. Are we clear? I want you to see or let you know if you don't know the orientation, you cannot use this technique. More important than anything else. Okay? The last example, as I said, we do the worst examples. Okay, we don't do simple stuff. So this is also available on your notes. Now it make all this look easy. You get what I mean, right? Where are the... Hey, it got missing. Wrong week. Right. If the rod AB is rotating with an angular velocity of omega AB, determine the angular velocity of the rod CD at the instant shown. Okay. This is a three-link member. You all have studied linkages, yes or no? In 2D or 3. Are you all studying linkages yet? Have you all studied chem yet in 2D? No? Okay. Maybe you'll learn it later. Okay. So this is a linkage design. Okay. So over here, we already know the orientation. Okay, we know the orientation of VB and what? BC. What we want to find out is what is omega what? CD. Okay. So what do we know? Okay, hold on. So we are aware that if we draw a line joining point A and point B, okay, and then if I were to rotate this by 90 degrees, We know this is our what? We know that this is our VAB. Okay. From here, we also know that VA is equal to 0. We also know that BD is equal to what? 0. Okay. And next, I'm going to construct CD. Right. So when we construct CD now, right, we know that VCD, again, will have this 90 degrees. Right. So we also know the orientation already. So this is our VCD. And when that's the case, that's going to be good news. Yes or no? Right? We have good news. Okay. So let's look at what values we know first. Okay. So we are going to now consider rigid body AB. Okay. So if I'm going to bring this out into IC domain, come on. Hey, please. Okay. I'll take everything out. Okay. We know that this is point A, and we also know that this distance right is 2 inches, and this is 90 degrees. The fact that VA is equal to 0, okay, this is our instantaneous center. Point A is also our what? Instantaneous center for rigid body AB. So therefore, VAB is equal to omega AB multiplied by the distance AB. So this will be equal to, I don't think I need to, yeah. Okay, so this is equal to omega AB is 3. AB is 2. So 3 times 2 is equal to 6 feet per second. Okay. So now we know, not our, this is our VB, sorry. Okay. Now, so the next thing that we're going to do now is we have to link or analyze rigid body BC. Okay. So I'm going to now sketch a distance from here to here. Okay. Then we are going to IC domain. Now, for this problem, we can use instantaneous center all the way, okay? Because we know the what? We know the orientation. Okay. So I'm going to now take this, and I'm going to paste over here now. And I'm going to have this, and then I'm going to rotate by 90. Okay. Then another thing that's missing is this. The important things are all missing. Then I'm going to rotate by 90. And then I will have this diagram so I will not get lost like before. Okay. So we know now, let's concentrate on AB now. VAB. Or BA, Eugene. Can you all change this to BA, please? And then this is BC. I do apologize, my bad. Okay, change this to BA. And then change this to BC. And then now, I want you to focus on this now, okay? So we know that this is 90 degrees, right? And this is 90 degrees to BC. And then I'm going to now project a line. Hopefully, crap, it won't work. It's okay. Okay, so this is 90 degrees. So now what we have identified that over here, this is our instantaneous center. Okay. And then over here, this is our point B, Eugene. And then over here, this is our point C. I make another mistake again. Sincerely apologize. This is BB. Okay. So over here, this is BB.